Good afternoon, everyone. Welcome to the second session on integral calculus. Last time we talked about the basic formulas of integral calculus, and now let us go further ahead. So we talked about these formula for differentiation, and then we have talked about these formula for integration. Okay. So we know that integration of x raised to n is x raised to n plus 1 upon n plus 1. Integration of dx is equal to x. Integration of e raised to x is e raised to x. And then we also talked about e raised to ax. Suppose I want to integrate e raised to ax, it will be e raised to ax upon a. And then integral of 1 upon x will be equal to log x, and integration of a raised to x will be a raised to x upon log a to the base e. Okay, these are the formula that we looked into. Now the next set of formula that we have is this that we discussed was 1 upon x square minus a square, which is equal to 1 upon 2a log of x minus a upon x plus a plus c. Always remember, in integration, we always have a plus c or plus k as a constant. Only when we have definite integrals, we don't have k or c. Then integral of 1 upon a square minus x square is 1 upon a log of a plus x upon a minus x. So these are the two formula for x square. Then we have a formula for 1 upon under root of x square plus a square and 1 upon under root of x square minus a square. Then we have formula for under root of x square plus a square, but there is no, it is not in the denominator, but it is in the numerator. Okay, there is no denominator of a here. So these are the two formula for integration of under root of x square minus a square and x square plus a square. Okay, these are some of the formula that you need to learn. So you can do that by writing them down every day. So you will be able to learn them up well. Now coming to the next topic, that is integration by parts. Like we talked about differentiation of multiplication of two functions, remember that? So similarly, we are going to do integration of two functions u and v. Now here what you have to remember is that there is a rule called as ILID. Okay, I stands for inverse, L stands for log, A stands for algebraic, T stands for trigonometric, and E stands for exponential. Okay. As far as our syllabus is concerned, you just have to remember this, because we are not dealing with sums in inverse and we are not dealing trigonometric problems here. So remember that when you have multiplication of two functions u and v, which is the function that you should take as u and which is the function you should take as v is defined by these rules. So first, if you have logarithmic function, algebraic function and exponential function, this is the order. That is, this will come before this. So now in differentiation, we did not have that kind of problem because the formula was such that we were able to differentiate whichever we took as u and whichever we took as v. Here we need to know this rule. Okay. So let us try and do the sum. Excuse me. Now the question is, find the integration of x e raised to x dx. Here we have to remember L, A, E. So logarithmic will come first, then algebraic, and then exponential. What is happening here? What is x? X is a algebraic function. What is ex? It is an exponential function. So is algebraic coming before exponential? Yes. So we don't have any problem. So here u will be equal to x and v will be equal to e raised to x. So u is x, which is the first function, and v is e raised to x is the second function. Okay. So what is the rule saying? Here it is saying that integral of first function, I'm writing it in words also so that you are able to remember it. Integral of first function into second function dx is equal to first function into integration of second function. Minus integration of, pay attention, minus integration of differentiation of first function into integration of second function. Okay, dx. So what is it saying? When I have two functions u and v, the integration of the multiplication of this will be equal to first function into integration of second minus integration of derivative of the first function. Remember here it is derivative of the first function into integration of the second function. This will be same as this. Okay. So once you've understood the formula, let us try and do this. So in the given sum, we have found what is u, what is v. Okay, now let us substitute and see. It is saying that integration of x e raised to x dx is equal to first function is x, into integration of second function, so integration of second function minus integration of first derivative of first function d by dx of x into integration of second function. Second function is e raised to x dx. Okay. Now, first I will do this derivative and then I will multiply it with the integration of the second and then again find the integration. So this is equal to x. Integration of e raised to x, we know is e raised to x. So this is x into e raised to x minus, what will this be? d by dx of x. Derivative of x is 1. So minus integral of 1 into, what is integration of e raised to x? E raised to x. So it will be e raised to x dx. Now what is 1 into e raised to x? E raised to x. So this will be equal to plus c. So this is equal to x e raised to x minus integral of e raised to x dx plus c. What is integral of e raised to x? I know it is e raised to x. So this is equal to x e raised to x minus e raised to x plus c. So in some places you may even have this written as equal to e raised to x into bracket. We take out e raised to x common. So this is x minus 1 plus c. Okay. Hope you have understood this. This is an important rule. Yes, Shambhavi, good afternoon. Shiba, Shambhavi, Harshita, Vidya, Chandan, Bhumika, Jaspreet, Taruna. Taruna, there is a timetable given in the BOS website. You have 2 classes every day. Okay, so you can just check on which subjects are happening when. Okay. So I hope you've understood this. So I will just repeat it for all of you. So what is the rule saying? Rule is saying that when I am integrating integration of u into v, I have u into integral of v minus integration of d by dx of u into integration of v dx. What is the rule that we have to follow? We have to follow Eilert rule, but we don't talk about I and T here. We only need to know LAE. We need to remember this order LAE. So L stands for logarithmic function, A stands for algebraic function, and E stands for exponential function. So we have solved this problem over here. We'll be doing a few more problems, so don't worry. Then we even have this type of questions. Okay, we have questions on applications. So here they are saying find the equation of the curve. This question is on page 8.32. So find the equation of the curve whose slope at xy is 9x. Slope is, we have talked in differentiation chapter, right? At xy is 9x, which passes through the origin. Okay, so this is also very important. Passes through the origin. Now, if I want to find the equation of the curve, what is it's saying? Find the equation of curve whose slope is. So, we need to find the equation. So, what will that be? Y is equal to something in x, right? So, on the left hand side, we will have y. And on the right hand side, we will have a function of x. So, what is given to me is given as slope. How do I write slope? Slope is written as d by dx of y. Okay. D by dx of y is given to me as 9x. Right. So, this means that dy is equal to 9x dx. Okay. Dy is equal to 9x dx. Integrating on both sides, we get integral dy is equal to integral 9x dx. Integration of dy will be y. What will this be? This will be 9 integral x dx. What is integration? Which formula will be used? We will use integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So, this will be equal to 9. And how much is it? X raised to? X is raised to 1. So, you will have 9x 2, 1 plus 1, 2 upon 2 plus c. Okay. This will be my equation. But the answer doesn't end over here. What is the saying? This curve passes through origin. Okay. Which means we have x is equal to 0 and y is equal to 0. Right? When it is passing through the origin. So, if I have this y is equal to 9x square upon 2 plus c. So, I put x is equal to 0, y is equal to 0. So, I have 0 is equal to 0 plus c, which means c is equal to 0, right? So, that the constant is equal to 0 over here. So, required equation is what? Required equation is y is equal to 9x square upon 2. Okay, so required equation is 9x square upon 2. Okay, is that clear? Amisha, why is there a 2y? It is simply y, right? There is no 2y. Because it is integration of dy. Integration of dy is integration of 1 dy. What is the integration of 1? It is y. Okay. Yes, Shiba. Good. Yes, Amisha. The earlier answer was correct. Right. Okay. Very good. So you're following everything. That's a very good thing. Now there are certain rules like we had in differentiation also. So if I have a constant which is multiplying the function and we want to find its integration, the constant will come out of the integration sign like we did just now. Okay, like we had here 9 integration of 9x, so we took 9 outside and then we have integration of x. Okay, and by the way, this is 1. Okay, x raised to 1. Then we have, if I have addition of 2 functions and we want to find its integration, it will be the integration of the first function plus integration of the second function. If I have subtraction, then it will be integration of first function minus integration of second function. Also, there is this important one that you may get for theory also. This one over here, just let me change the color. Okay. This is saying that if I have integration of e raised to x of fx plus f dash x. What does f dash x mean? It is the derivative of the function fx. If I have ex into fx plus f dash x, this is equal to e raised to x fx plus c. Okay. So this you can get for theory question on it. And then this is important. This is saying that if in integration I am able to see that I have a function fx in the denominator and I have its derivative in the numerator. That is, I have a function in the denominator and I have its derivative in the numerator. Then f dash x upon fx dx is equal to log of fx plus c. Okay, so you can do that. So these two you can get for theory also questions. Now on page 8.32 you even have definite integrals. So what happens in definite integral? Up till now what we have done was we are finding the integration. Okay, there is no limit over there. So over here, once I want to find the integral value of a function within a given limit. So I have put a limit a, that is the lower limit, and b, that is the upper limit. And if I want to find the integration of the function within those limits, then it is called as definite integral. These are theory questions that you may get. It says that integral of fx dx, x going from a to b. How is it said? Integral of fx dx, x going from a to b. This is x, value of x from a to b is equal to minus of, if I change the limit, so I make the upper limit as the lower limit and the lower limit as the upper limit. So this becomes from b to a, fx dx. Okay. So the quantum will remain the same, but the sign is going to change. Okay. You can even have, like suppose I have limit from a to b, then I can go from a to c and then c to b. Okay, that is also possible. So if I want to travel from a to b, like if I'm traveling, then if I have a point c over here, so integration will mean I can go from a to c and then I can go from c to b. It is as good as going from a to b. Okay. But remember, this is there. A is less than C is less than B. Okay, I cannot have C over here and A over here and B over here. Then this rule will not apply. This applies only when A is less than C is less than B. Okay. So A, C and B. Okay. So this way, if I find the integral from a to c, and then I find from c to b, it is as good as the given interval. Now, the next is this. Again, this is saying that if I have an integral, 0 to a, okay, 0 to a of fx dx, This is equal to integral 0 to a of f of x minus a. This a, if I am subtracted from x, then also I will get the same result. Okay. Then you have, if fx is equal to f of a plus x, then it will be multiplied n a. So 0 to na, it will be n into 0 to a fx dx. And minus a to plus a, fx dx is equal to 2 times integral 0 to a fx. So what is happening over here? It is minus a to a fx dx. So what is minus a to a? What does it mean? Like, this is your number line. This is my origin, 0. What they are saying is, if I have something like minus a to plus a, so when I want to find the integral from minus a to 0 and from 0 to plus a. Okay, we did this right now. A to C and C to B. So same thing. This is a particular case of this first formula. This is saying that I should find integral from minus a to o, origin, and origin to plus a. So instead of doing that, if I just find it for 1, that is 0 to a, I just have to multiply it by 2. Why? Because this integral and this integral will be equal. So this is equal to 2 times integral 0 to a of fx dx. Okay. Okay. Hope you've understood here. Now let us try to do the sums, because I think the sums, it becomes easier when we are doing sums. Then understanding this formula become easier. The other formula that we have given in definite integral, you may get them for theory. Okay, so you don't have to worry a lot. Bhumika, sometimes they will ask you, this is just there for your theory question. This formula is meant for bigger integral questions. So what you have said is right, that when in the question they are giving only a to values of a and b, where do we get the value of c? So this is not a question for that. It is a question for understand whether or not you know the formula, that a to b, you can go from a to c and then c to b. Okay, so that is there for your understanding. Jaspreet, there is there is no page number for theory questions here. You only have exercise 8B. So, but I'm telling you that in the exam you may get a question like this. Okay, so I'm just saying that this may be a theory question where they will give you 4 options. In one will be the correct answer, and the others may have some mistake in the plus or minus sign, or the formula may be incorrect. Okay. Is that clear? Right. Yes, Bhumika. Now what happens here is, suppose I have this question that is saying that integration of 0 to 2 x raised to 5 dx. Okay. Now don't worry about the definite integral. Don't worry about 0 and 2 right now. Just think about this being a question of integration of x raised to 5 dx. What will I do? I will use which formula? X raised to n, integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c, right? So here what is happening is, we don't need the c over here. Why? Because already I know the limits. I want to find it from 0 to 2. So this will be equal to x raised to 5 plus 1 upon 5 plus 1 x is going from 0 to 2. Okay. So this is equal to x raised to 6 upon 6. Okay. This is equal to x raised to 6 upon 6. X going from 0 to 2. Now what we have to do is, we have to first put in the upper limit and then the lower limit. So this is equal to, first what is the value of x on the upper limit? 2. So it is 2 raised to 6 upon 6 minus, what is the lower limit? 0. 0 raised to 6 upon 6 Now 0 raised to 6 I know is 0. So 2 raised to 6 is how much? 2 raised to 5 is 32. 32 into 2 is 64. So this is equal to 64 upon 6 minus 0. This 2 3s are 2, 32s are, answer is 32 upon 3. Okay. So what I have done, I have taken the question, I have just solved it like normal integral question, and then I put in the limits. So first I put in the upper limit and then I put in the lower limit and find the answer. Okay, let us do one more sum. We did this. Okay. Now this question, integral 1 to 2 x square minus 5x. Now this is equal to, we use the rule of addition of functions. So this is equal to integral 1 to 2 x square dx minus integral of 1 to 2 5x dx plus integral of 2 dx 1 to 2. Now what will this be? This is equal to x square. The formula will be x raised to 3 upon 3 going from 1 to 2 minus this will be 5x square upon 2 1 to 2 and plus 2x going from 1 to 2. Okay. Now this is equal to, this is as good as writing x cube upon 3 minus 5x square upon 2 plus 2x, x going from 1 to 2. Now what will I do? I will put in all the, put in the upper limit first and then put in the, with the minus sign, then I will put in the lower limit. So this is equal to, what is the upper limit? 2. So 2 cube. Instead of x, I am writing 2 upon 3 minus 5 into 2 square upon 2 plus 2 into 2. There is a minus sign. From this, I subtract what? I subtract this. So this is 1 upon 3. 1 cube is 1 minus 5 upon 2 plus 2. Okay, because everywhere x is 1. So I get this answer. This is 8 upon 3 minus 20. Okay, because this is 5 into 4 is 20 upon 2, that is 10. Okay. Ten plus 4. Okay. And don't be in a hurry. Solve the bracket completely and then put in, then use the sign. Now what will be the LCM here? 3, 2, 1. So LCM is 6. So this is 2 minus 15 plus 6 into 2. Right? 2 minus 15 into 6 into 2. And what will be the here? 8 by 3 minus 6. So this is equal to upon 3, 8 minus 18. Because 3 6 are 18. Now this is minus 10 plus 4. So minus 10 plus 4 is minus 6. Minus 6 into 3 is minus 18. Minus, how much is this? Minus 15 plus 12 is minus 3. Minus 3 plus 2 is minus 1. So this is minus 1 by 6. So this is equal to 8 minus 18 is how much? Minus 10 upon 3. Now this minus into minus will give you plus. So this becomes plus 1 by 6. Now what is the LCM of 3 and 6? 6. So this will be minus 20 plus 1 upon 6. How much is minus 20 plus 1? Minus 19 upon 6. Okay, so this will be your answer. Just check whether the answer is correct. Yeah. So we got the answer. right? Hope you've understood this definite integral. So all you need to do is find the integration first and then put in the limit. Okay, now let us try and solve as many sums as possible from our exercise. Okay. Now, can we do this? Can you just put in the answer option? Now this is a normal sum. Which formula will I use? X raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. And I'm using the rule integral of c fx is equal to c integral fx, where c is a constant. So I have integral of 5x square dx is equal to 5 integral of x square dx, which is equal to 5 into x square will be x raised to 3 upon 3. Where did this 3 come from? 2 plus 1 is 3 upon 3. N plus 1. Here n is equal to 2 plus c. So answer is 5x cube upon 3. See, now be careful. Here in place of constant c, they are using the letter k. It is one and the same thing. Now, you may get confused between a and b, but we have x cube in the numerator. So a is not the correct answer. Okay. A is not the correct answer. C is not the correct answer. So we have 5x cube upon 3 plus k, which is same as this. So B is the correct answer. So don't be in a hurry. Now they are asking you to find the integration of integral of 3 minus 2x minus x raised to 4 dx will be equal to integral of 3 dx minus 2 integral x dx minus integral of x raised to 4 dx. Okay, initially you should write it like this while practicing, and then once you get used to this, you can directly solve this also. Okay. What will this be? This will be 3 integral of 1 dx minus 2 integral x dx minus integral of x raised to 4 dx. 3 integral of 1 dx I know is x minus 2 x raised to 1. So this will be x raised to 2 upon 2 minus x raised to 5 upon 5 plus k. This 2 will get cancelled with this 2. We have 3x minus x square minus x raised to 5 upon 5 plus k. Now, I can see it right away that this is not the correct answer. Okay, so this is wrong. 3x minus x square minus x raised to 5 plus k. So this is the correct answer. Now what is the difference between B and C? B and C, there is a difference in the sign with x raised to 5. Okay, but because in the sum we had minus sign over here, so this becomes minus x raised to 5 upon 5. Okay, understood? Now let us go to the third sum. Yes, Shiba. Yes, Harshita, Bhumika, you got the correct answer. Very good, very good. Mohammed. Yes, Jaspreet also. Jaspreet, not C, but B is the correct answer. Okay. Now let us go to the third sum. Now the third sum, they are asking us to find us the integration of this function. So what do we have? We have integration of 4 x cube dx plus integration of 3x square dx minus integration of 2x dx plus integration of 5 dx, which is equal to, this is equal to 4x raised to 4 upon 4 plus 3x raised to 3 upon 3 minus 2x square upon 2 plus 5 into. Now remember that this is integral of 5 dx. So this is what? That is 5 integral of 1 dx. So what will it be? 5x plus c. Now this 4 will get cancelled, this 3 will get cancelled, and this 2 will get cancelled. We are left with x raised to 4 plus x raised to x cube minus x square plus 5x plus c. Okay. Why I'm even talking about the options here is because so many times it happens that we've got the correct answer by solving. But while thinking, we make the mistake. Okay, while circling the correct answer, we make a mistake. So this is x raised to 4 plus x cube minus x square. So plus, plus, minus, plus. Now, what happens is, what is the difference between option A and option B? Same thing. X square, x raised to 4 has plus sign, right? X raised to 3 has plus sign, right? X raised to 2 has minus sign in both the options, right? 5x has plus sign, yes. But the very important factor here is plus x. So that is why even though A and B are same in terms of in terms of power of x, in terms of signs of x, what is difference is plus x, and that is why this makes it the correct answer and this is the wrong answer. Okay, C is out of question, C is not the correct answer. बट जल्दी में क्या हो जाता है, अरे सब आ गया, जो नीचे लिखा है वही ऊपर लिखा है, आप देख रहे हैं एक्स रेज टू 4 प्लस एक्स क्यूब माइनस एक्स स्क्वायर प्लस 5 सब वैसे ही आ गया, लेकिन प्लस सी या प्लस के का डिफरेंस होने की वजह से ए और बी में आपको, सो जस्ट बी केयरफुल इन इंटीग्रेशन and in like even in statistics you have to just be careful with the signs and with what are the values that you get. Okay, so this sum I particularly wanted to show you like even selecting the correct option is such an important thing. Now the fourth sum is integral of x square minus 1 dx is equal to integral of x square dx minus integral of 1 dx. So what is this? This is equal to x cube. Okay, wait. Right. X cube upon 3 minus x plus k. Option A is not correct. Option C is not correct. Option B is the correct option. Okay. So integral of this, you can write this as x cube upon 3 minus x plus k. Fifth question. Okay. Here you can use it by using the formula UV formula, or you can use it directly by actual multiplication. So either of the method is okay. Use whichever method is more comfortable. 1 minus 3x into 1 plus x dx. But to be on the safer side, let us multiply this first. What will it be? 1 into 1 plus x will be 1 plus x. minus 3x into 1 will be minus 3x. Minus 3x into plus x will be minus 3x square. There is no dot here. Okay. Minus 3x square dx. Now minus x plus x minus 3x will be minus 2x. So this is equal to integral of 1 minus 2x minus 3x square dx. Okay. Which is equal to, what is the integration of 1? It will be x. What is the integration of minus 2x? It will be minus 2x square upon 2. What will be the integration of minus 3x square? It will be minus 3x cube upon 3 plus k. So this 2 will cancel with this 2. This 3 will cancel with this 3. You will get x minus x square minus x cube plus k. Okay. X minus x square minus x cube. Again, you can see the A and C are same. Okay. Here in B, you are getting plus x. You are getting, here also is plus x, but x cube here has plus sign, but x cube here has minus sign. So therefore, B is not the correct answer. Why? Because sign is different. Now left with A and C. Again here it is the plus k. That is why this will be the correct answer. Okay. Now let us go to the sixth sum. So they are asking you to find the integration of root x minus 1 upon root x. We did a similar sum earlier, yesterday. Integral of root x minus 1 upon root x dx. Okay. This will be equal to integral of root x dx minus integral of 1 upon root x dx. Now what, remember what I told you, root x can be written as what? X raised to half. Okay, remember that? Just let me put it in a different ink so that you remember. Remember these rules because this will give you confidence. If you remember all these things, you must remember that root x can be written as x raised to half and 1 upon root x will be written as x raised to minus half. This is very important that you remember this. So we have what will be this? This is equal to integral of x raised to half dx minus integral of x raised to minus half dx, right? So from here itself, I know I'm going to use the formula integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So what will happen over here? This is equal to x raised to half. So this will be x raised to half plus 1 upon half plus 1 minus integral of x raised to minus half will be x raised to minus half plus 1 upon minus half plus 1 plus c. What will be half plus 1? 3 by 2. So this is x raised to 3 by 2 upon 3 by 2 minus x raised to half, because minus half plus 1 is half, and this will be again half plus c. Any fraction in the denominator will get flipped. Okay, any fraction in the denominator will get flipped. So this will be equal to 2 by 3 x raised to 3 by 2 minus 2 x raised to 1 half plus c. This is equal to 2 by 3 x root x minus 2 root x plus c. Let us see whether we have any of this option. Okay, they're very good. First option they've given in, see, in terms of 3 by 2, second option they have given in terms of root. Okay, so that is why you must know that the answer can come in any form. Now let us see. 2 by 3 x raised to 3 by 2 minus 2 x raised to half plus k. So A is your correct answer. Okay, so for this question, A is the correct answer. Now integration of this. Now this sum is also very important because sometimes we get the correct answer, but because the option is not there and we are afraid of the topic, we get confused and we spend such a lot of time on whether or not the answer is correct, what did I do wrong, we start thinking on those terms. Yes, Priyanka, right. Chandan, yes. Poonam, very good. Shibba, Omisha, Shambhavi. Yes. Jaspreet, you got the answer for 5th correct. Right? So now let us see this. Now we have integration of px cube plus qx square plus rk plus w upon x into dx. Now what will be the integration of x cube? Integration of x cube will be x raised to 4 upon 4. So this is p because p is a constant. So p x raised to 4 upon 4 plus q into, what is the integration of x square? What is the integration of x square? It will be x cube upon 3. What is the integration of rk? R and k both are constant. So integration of a constant will be a constant into x. So this will be plus rkx. What will be the integration of w upon x? It will be equal to plus w. What is the integration of? Let me show it to you. Integration of wx dx, w upon x okay. W is a constant, so it will be w integral of 1 upon x dx. What is integral of 1 upon x? You know, this is w log of x. Okay. So for this portion, w upon x, I am showing it to you over here. The integration of this w upon x dx will be equal to w integral of 1 upon x dx, which is equal to w log x. So this is equal to w log x plus c. Now what happens? In option A, we directly know this is not correct. C also we know is not correct, and px cube we know this is not correct. So D will be the correct option. Here what has happened? The integration is so different from all the options. Okay. So don't worry. Sometimes it may happen because the answer is none of these. Because in multiple choice question you may have none of these as the option. So just do it very well and then check whether or not you are getting the correct answer. Use method of substitution to integrate the function fx is equal to 4x plus 5 raised to 6. Okay. See, so good that the institute has already given you the hint on which method you are supposed to apply. So you don't have to worry there. Only you have to do the sum properly. So I have integration of fx dx is equal to integration of 4x plus 5 raised to 6 dx. Now what will be the step? Step 1, substitute. What do I substitute? Substitute 4x plus 5 is equal to t. Okay. Differentiating on both sides, we get 4 dx plus 0 is equal to dt. 4x plus 0, because derivative of a constant is 0 and derivative of x is what? Dx. So 4 dx plus 0 is equal to dt. So what is dx? It is equal to dt upon 4. So that step 2 will be substitute in the integral. What will I substitute? I will substitute for, okay, I will substitute this the t got rubbed away. Okay, I will substitute this, and very important is sometimes we forget to do it, and I have to also substitute this. Okay, these two I need to substitute. So what will happen is this will become integral of, instead of 4x plus 5, what am I writing? T. So this has become t raised to 6. Instead of that 4x plus 5, I'm writing t raised to 6. Instead of dx, what am I going to write? dt by 4. So this is equal to into dt by 4. I'm repeating, instead of 4x plus 5, I'm substituting what? T. So then it will become t raised to 6. And instead of dx, what am I substituting? dt by 4. So this is equal to, what is it? This is equal to 1 by 4 integral t raised to 6 dt. This is using x raised to n and is equal to x raised to n plus 1 upon n plus 1. This is equal to 1 by 4 t raised to 7 upon 7 plus c. What is 4 into 7? 28. So this will be 1 upon 28. What is t? I will resubstitute. So step 3 will be resubstitute back. So instead of t, I am writing 4x plus 5 raised to 7 plus c. So which of these answers is correct? Or here they are taking k, so just let me also write k. So plus k. Okay, so 1 upon 28. Yes, A might be the correct answer. 4x plus 5 raised to 7, right? Plus k. Okay, so here. 8 will be the correct answer. A will be the correct answer for question number 8. So we go in next substitution on a further substitution sum. Just let me check whether there are any questions. Kadir, you're saying the answer is B? No, no, no. That's not possible. A is the correct answer. You are looking at question number 8 of exercise 8A. We are doing 8B. 8A is for differential, 8B is for integral. Okay, so you by mistake you are seeing the answer over there for 8A. Okay, so 8B, the answer, exercise 8B, question number 8, the answer is A. Now let us do the ninth sum. I hope you are able to understand. Just put it in the chat box whether or not you are understanding. And we are taking all the sums step by step so that you will be able to see that there is nothing to be afraid about in differentiation and integration. Okay. Now again here, they very nicely told you that use the method of substitution. So we will do the step 1. Step 1, what is it? Substitute for the function. Substitute function as equal to t. Step 2, what is it? Differentiate. Okay, differentiate. Then step 3 will be resubstitute for t. Okay, so these, if you remember these 3 steps, you will not have any problem. Okay, now what are we going to substitute? What is the function? Okay, x square plus 4. Let x square plus 4 be equal to t. X square plus 4 be equal to t. This is my first step. Second step, differentiate on both sides. What is the derivative of x square? It is 2x dx. What is the derivative of 4? 0. What is the derivative of t? dt. So what do I get? X dx is equal to dt upon 2. Okay. Now, what will my equation become? It is integral of x square plus 4 raised to 5 dx. I will rewrite this as this is equal to integral of x square plus 4 raised to 5 x dx. Okay. I am writing this as, what is the step that I have done? I am writing this as x dx. Okay. This x over here, I just wrote it next to dx. This is all multiplication, so I can change the order. So what am I going to do? I am now going to substitute. Okay. So this will now become, what are the 2 substitutions I need to do? This is substitution 1 and this is substitution 2. Okay, remember this. So what will happen now is, now this will be equal to, instead of x square plus 4, what am I going to write? Integral of t raised to 5 and x dx, what am I going to write? dt by 2. Okay, instead of this, I'm going to write dt by 2. Now what will I get over here? 1/2 integral of t raised to 5 dt, which is equal to what? 1/2. T raised to 5 will become t raised to 6 upon 6 plus k. So I have, this is equal to 1 upon 12 t raised to 6 plus k. Now we will do the step 3. We will resubstitute for t. So this is equal to 1 upon 12. What is t? T is x square plus 4. What is t? T is x square plus 4 from here plus k. X square plus 4 raised to, how much is it? 6. Okay, just let me write it down a little neatly. Okay. So what do I have? Step 3 is resubstitute. Resubstitute for t. So I get 1 upon 12. Instead of t, what am I going to write? X square plus 4. So this is equal to x square plus 4 raised to how much? 6. So raised to 6 plus t. Let us see whether we have this option 1 upon 12 x square. Yes, B option we have 1 upon 12. So this will be the correct option. So B is the correct option. Okay. See here they just put in the line and C option. They did not write anything. So C is not the correct option. Only B is the correct option. Okay. So before we go to the next sum, we'll take the break. Okay, let us see. Okay, just let me show you this. Integrate x plus a raised to n and the result will be. Okay, so x plus a raised to n plus 1 upon n plus 1. X raised to x plus a raised to n plus 1 upon n plus 1. X raised to x plus a raised to n plus 1. Again, here what is happening is, what is important is this plus k. Okay, so that is why we have A as the correct answer. So, yes, because the next sum is a bigger sum, so we will take the break. We will take a break of 5 minutes, and it is 3-1. We will be back by 3-6. Okay. Akash? Yes. Break, please. Okay, Bala Lakshmi, you did not understand this 9 sum. So here what are we doing? In substitution, first we are going to substitute for a function. Okay, we'll substitute as t. The second step is differentiate it. So we will get something on in terms of dx on the left hand side and something in terms of dt on the right hand side. Then according to what is there available in the function, I'm going to write x dx, x square dx, whatever it is, dx term on the left hand side and dt terms on the right hand side. Okay, first step, substitute the function as t. Second, differentiate. Third, substitute the value for the function and ds in the integrand in terms of t. So we did that, and then we will solve it as a normal integration, and then last step will be resubstitute for t. Okay, so what have we done here? We have put in x square plus 4 as t, then we differentiated it, then we will put in instead of x, okay, we need what? X dx here. We need x dx. So we need x dx. So what do we have in the function? We have x. You can see x here and dx here. So we will just written x square plus 4 first and then we wrote down x dx. Okay. So instead of x dx, what am I writing? Dt by 2. Okay. Dt by 2 for x dx, and t raised to 5, I'm writing for x square plus 4 raised to 5. And then I solve normal. Integral of t raised to 5 is t raised to 6 upon 6, and I get the answer. Okay, I hope, Sanjay Lakshmi, you've understood. Now let us go to the 11th sum. Now what is the 11th sum saying? It is saying 8x square upon x cube plus 2 whole cube. Now, let x cube plus 2 be equal to t. Now first, first I should see whether I can divide it. What is the power of x in the numerator? Power of x in the numerator is 2. What is the power of x in the denominator? 3 into 3, that is 9. So can I divide the numerator with the denominator? No. So I cannot use the division method. So the next method that I do is the substitution method. So that is why I put x cube plus 2 to be equal to t. That is my first step. Now second step is finding the in derivative. So this is equal to 3x square dx to be equal to dt. Okay. So I get x square dx to be equal to dt upon 3. Now what will happen over here? What is the equation I've got? Integral of 8x square upon x cube plus 2 whole cube dx. Now here, from here you can see I already have here x square dx. Okay. So here I can use this. For x square dx, I can write it as dt by 3. And for x cube plus 2, I'm going to write this. This is equal to 8 integral x square dx upon x cube plus 2 raised to 3. Whatever I write for x square dx, I write down dt by 3. So this is equal to 8 integral dt by 3 upon, what is this? This is t cube. Now this will be equal to 8 upon 3 integral of t raised to minus 3 dt. Okay, remember a raised to 1 upon a raised to m is equal to a raised to minus m. Indices chapter. So instead of t raised to 3 in the denominator, I will write it as t raised to minus 3 dt. So what do I have? This is equal to how much? 8 upon 3 t raised to minus 3 plus 1 upon minus 3 plus 1 plus c, which is equal to 8 upon 3 into minus 2. T raised to minus 2 plus c. Now I will resubstitute, and this is 2 ones are, 2 fours are, and there is a minus sign, so this will be minus 4 upon 3. Instead of t raised to minus 2, instead of t, what do I write? T is x cube plus 2. So this is equal to minus 3 x cube plus, okay, it's not fitting over here. Let me write it down. Okay, so this will become minus 4 upon 3. This 2 and 8 cancels. So this is minus 4 upon 3. Instead of t, what do I write? X cube plus 2. X cube plus 2 raised to minus 2 plus c, which is equal to minus 4 upon 3. I have 1 upon x cube plus 2 raised to 2. Okay, a raised to minus m is 1 upon a raised to n plus c or k, whatever option says. So what do I have? Minus 4 by 3 x cube plus 2 square plus k. So that is why a is the correct answer. What is the difference between a and c? A and c, the difference is between this minus sign. Else both are same. A and C answer is same, but because there is a minus sign, the option A is the correct option. Isn't it? Yes. Now here, what has happened here is A and B both you are getting as correct, but I think they made some mistake over here because both the answers are correct. Maybe they wanted you to have a different option. So, but B in the textbook they have marked B as the correct answer, but both are the same, you know. Both the answers are same because it is minus 4, 3 x cube plus 2 whole square. This is also minus 4 upon 3 x cube plus 2 whole square. Okay, so A and B are the same, but you in the exam, don't worry, you will not get two options as correct option. This may be something to do with printing. So B is the correct option. So as per the textbook, you get B as the correct option. Now let us see. Now they are saying use method of partial fraction, the integration of fx. Now see, here we don't need to use this because we already have the formula for this question. Okay, this is a question, like I was talking about theory question. So this is the theory question that I am talking about. They are saying use method of partial fraction, but I don't need to because I already have the answer. This is a question when we had those written exams. So that time you had to prove and you had to do it and show it to them. So now what is the function? 1 upon x square minus ax square. What is the function? 1 upon x square minus a square. And I've just shown it to you, the formula that we have done earlier. So what is the formula? Dx upon x square minus a square is 1 upon twice a log of x minus a upon x plus a. So here, as you can see, C option is the correct option. For question number 12, C is the correct option. Okay. Now, this is an important question. So, please be very careful. Here, what is happening? We are going to use the UV rule. And once we are using the UV rule, you have to use it twice. Okay. So, I have to find the differentiation and then I have to again find the I have to find the integration once and then I have to find the integration one more times. Okay. Now they are telling you use integration by parts. What is the rule I'm going to use? Very important. LRS. B. Usually they will give you in the order, but if they don't, then you have to see it. So this is my algebraic function and this is my exponential function. Are they in the order? Yes, they are in the order. So I have, what is the rule say? Integral uv dx is equal to u, that is the first function, into integral of second function minus integral of derivative of the first function into integral of the second function plus c. Well, let us say plus k. Okay. So now what happens is, what is my first function? First function is x square and second function is e raised to x. Okay. So using this, I find out. So integral of x square e raised to x dx is equal to first function. First function is x square into integration of second function. So into integral of e raised to x dx minus derivative of first function into integration of second function plus c. X square. Integration of e raised to x is e raised to x minus derivative of x square is 2x. So 2x e raised to x plus c. Because again this integration is how much? E raised to x. So this is e raised to x dx. So instead of 2 dx, now I'm writing only 1 dx. So write it clearly. So instead of this, so I have e raised to x dx plus k. Now what happens here is, again I have got an integration. What happens here is, this is not completely solved. Okay, that is the beauty here, that this I need to solve this again. And how do I do it? I again use the same principle uv. Now here in the second time, now what will be that function? See, I have integral of 2x e raised to x dx. This is equal to 2 integral of x e raised to x dx. Okay. I'm just showing it to you from here. What will be integral of x e raised to x dx? This will be equal to 2 into bracket first function into integral of second function. Here again I have to see whether the rule LAE is being followed. Yes, it is being followed. So first function into integration of e raised to x is how much? E raised to x minus integral of, what is the derivative of the first function? X will be equal to 1. And what is the derivative of e raised to x? It will be e raised to x dx. Now, what will this be? This is equal to 2x e raised to x. What will be the integration? Minus e raised to x. Okay. So, integral of 2x e raised to x is this much. Now, I will substitute this over here and I get x square e raised to x minus, instead of this, what am I going to write this? Minus 2x minus 2x e raised to x minus e raised to x plus k. This is equal to x square e raised to x minus 2 into x into e raised to x is minus 2x e raised to x minus 2 into e raised to x will become plus 2 e raised to x plus p. Let's see which answer. Oh, it was 3x. I've taken e raised to x. Okay, here I have taken the question as e raised to x. So this question, this answer is there. This is the integration of x square e raised to x dx. Okay. So this is the answer for this. Let me now take it for x square e raised to x. Okay. I will do it for that also. Okay. So just okay, so you may get a question like x square e raised to x, or you may get a question with x square e raised to 3x also, or you may have any number 2x, 5x, you can have any number for exponential raised to. Just let me check the query also. I hope you've understood this question, and I will take it for e raised to 3x also. That is, question is 13th, e raised to 3x. Okay. U into integral of v dx dx. Okay, so now the given question is here e raised to 3x dx. Okay, integral x square e raised to 3x dx. So what is my first function? First function is u square, x square. What is the second function? Second function is e raised to 3x. This is equal to u, that is the first function, that is x square, into integral of e raised to 3x dx minus integral of d by dx of x square into integral of e raised to 3x dx into dx. Now what will this be? This is x square. What is the integration of e raised to 3x? Integration of e raised to 3x will be e raised to 3x upon 3 minus integration of, what is the derivative of x square? It will be 2x. What will be the integration of e raised to 3x? It will be e raised to 3x upon 3 dx. Okay, so what will this become? This is equal to x square e raised to 3x upon 3 minus 2 by 3 integral of x e raised to 3x dx. E raised to 3x dx. Okay. Now again we are going to use the UV rule for the second integration. Okay. The second term we are going to use the integration. So this is what will happen to the first term. It will be as it is. So this is equal to x square e raised to 3x upon 3 minus 2 by 3. What will happen over here? First function is x, second function is e raised to 3x. First function into integration of second function. So this is e raised to 3x upon 3 minus integration of derivative of the first function. What is the first function here? X. What is the derivative? 1 into e raised to 3x upon 3 plus c. Okay, so plus c is there. Now again I have an integration. What will the integration of e raised to 3x? It will be e raised to 3x upon 3. So this is first term as it is, x square up e raised to 3x upon 3. What will happen to the second term? Minus 2 by 3 into this. So this will be minus 2x e raised to 3x upon 3. Now this minus 2 by 3 into minus sign will become plus. So this is equal to plus 2. 3 into 3, this 3 multiplied by this 3 is 2. 3 into 3 is 9. And what is the integration of e raised to 3x? It will be e raised to 3x upon 3 plus c. So what do I get the answer here as? This is equal to, I will write it with another color so that it is visible. So this is equal to what? X square e raised to 3x upon 3 minus 2x e raised to 3x upon 3 then upon 9. So this 3 into this 3, this is 9 upon 9. And 2 by 9 into e raised to 3x upon 3 will be equal to plus 2 e raised to 3x upon 27 plus c. Okay, let us see which answer option we have. X square e raised to 3x upon 3. So, this so here obviously option B is not correct because it does not x square e raised to 3x. We don't have upon 3. So B option is incorrect. Now we have A, C or D. Let us see. A and C. X square e raised to 3x upon 3. X square. So in C we do not have x square e raised to 3x. We don't have a term in x square. So C option is also not correct. Now let us check whether or not the A option is correct or not. Okay, let us see this. X square e raised to 3x upon 3. Just let me. Now you can see the answer over here. So x square e raised to 3x upon 3. Do I have this term? X square e raised to 3x upon 3. Right. Now I have minus 2x e raised to 3x upon 9. Minus 2x e raised to 3x upon 9. Yes, very good. Then we have plus 2 e raised to 3x upon 27. 2 upon 27 e raised to 3x plus k. So A is the correct option for question number 13. Is that clear? A is the correct option for question number 13. Okay. Now let us go to the 14th sum. I hope you have understood. Only you have to do the steps 2-3 times. Okay. That is the only thing that you need to understand. Yes, Bhumika. Yes, it was e raised to 3x, right? Poonam. Yeah. So instead of 1, एक के ऊपर एक फ्री आपको क्वेश्चन सॉल्व करके मिल गया. एक वाला क्वेश्चन है एक्स स्क्वायर ई रेज टू एक्स वाला और दूसरा क्वेश्चन है एक्स स्क्वायर ई रेज टू 3x वाला. ओके, राइट. Neha, question number 12, there is nothing to explain. It is a formula. You just have to see the question. You have to learn the formula. So Neha, there is nothing to explain. This formula is already there in your book. So just learn that formula and you can easily apply it over here. You're just checking whether or not you know the formula. Right, Neha? Vidya, let me check. Okay. Vidya, you're saying this is, see, that is why in printing you may feel that this is in the numerator, but actually you can have it like this, na? It can be 4 by 3 into x cube plus 2, or it can be 4 upon 3 x square plus 2. But this B option is very clear, so B will be the correct option over here. Okay. You will never get such very close to answers. Okay, so B will be the correct option. Why? Because here it x cube plus 2 is clearly written in the denominator. Okay, Vidya. Okay, Neha, I hope you've understood. It's just a formula that you need to understand. Okay, more than the 13 sum, you will get questions like the 14 sum. Okay, it depends because the time frame is such less. So I think question like number like 14 will be more appropriate questions. Okay, now this is integral of log x dx. Now, as such, in integration, we do not have a direct formula for log x. Okay, we don't have a direct formula for log x, but I'm showing you the derivative. But once if this question comes directly, you already know the answer and you can use it. That is x log x minus x plus k. Okay, but because here we don't have to solve it and show, but here I will just show it to you. I will solve it and show it to you. The rule is LAE. Now logarithmic is first. We will be using by part. So I'm going to write this as in log x into 1 dx. Okay, so this becomes my u and this becomes my v. What is the formula? U v dx is equal to first function into integral of second function minus integral of derivative of the first function into integral of second function plus k. So what will happen here? Integral of log x into 1 dx will be equal to log x into integral of second function, that is 1 will be x, minus integral of derivative of first function, that is d by dx of first function is log x into integral of 1 dx plus k. So this is equal to x log x minus derivative of log x I know is 1 upon x. What is the integration of 1 dx? It is x dx plus k. Now this x will cancel with this. So what do I have? Again, I have integration of 1 dx. What is the integration of 1 dx? X. So this is equal to x log x minus x plus k. So integral of log x, this is a very famous sum for those of you who are doing maths, in your 12th standard. This is a very famous sum for prove that in your theory, in your board exams. But over here, you simply have to know this. Integral of log x is x log x minus x plus k. So here, because we don't have that option, so D will be the correct answer. None of these. Is that clear? So you need to know that integral of log x is x log x minus x plus k. Let us go to the 15th sum. Okay, I right now just did it, but still, yes. Yes, Bhumika, understood? Yes, very good. Priyanka, correct. Mansi, you're not able to see? You just check with your internet connection. Yes, Chandan, I'm not getting any answers for you. Question 16, Shiva. Yes, I'm taking that. Yeah. We are still at 15. Why are you running ahead, Shiva? Okay. We are still doing those questions, right? Now here again, I have to ensure that I'm using LAE, exponential, arithmetic, logarithmic, arithmetic and exponential. Logarithmic, algebraic and exponential. Logarithmic, algebraic and exponential. So what is my first function? First function is x. What is my second function? Second function is e raised to x. I am using the rule integral of uv dx is equal to first function integral of second function minus integral of derivative of first function into integral of second function dx. Okay. So now what will happen? Integral of x e raised to x dx is equal to first function, that is x, into integration of second function, integration of e raised to x is e raised to x, e raised to x, minus integral of, what is the derivative of the first function? 1. So this is 1 into integral of v dx is integral of this into 1 e raised to x into dx. This is equal to x e raised to x minus integral of e raised to x is e raised to x plus k. Okay. I can take e raised to x common because see, why I need to do that? Because this is my answer. But can I see the answer in my present form? No, I'm not able to see. In neither of the three options I can see that. So this is equal to e raised to x, I take it common. This is x minus 1 plus k. Now e raised to x, x minus 1 plus k. So where do I have? Okay. So A is the correct option because here there is plus k. Here we are missing the plus k. So that is why A will be the correct option. Okay. Now let us see this 16th question. Here you have to also use the concept of logarithm. Okay. So if you've done the chapter on log well, you will be able to understand the solution. Okay, now let us go to the 16th question. See, as I told you, we don't have the integration of log x, so we used it, used by parts and found it as integral of log x is x log x minus x plus k. Now for this is integral of log x whole square. Now what do I do? So here I am using the substitution method. So what is the substitution method say? First put the function equal to t, then differentiate, then substitute for t as well as dx, substitute for the function as well as dx, and then do the integration and then resubstitute for t. Okay, these are the steps. First step, substitute the function as equal to t. Second step, what do I do is I differentiate. And third step, for dx, I substitute in terms of dt. For the function, I substitute in terms of t. I find the integration. Then last step, I resubstitute for t. So I say let log x be equal to t. Let log x be equal to t. Now, what is x? So, remember the exponential form and logarithmic form in the chapter on log. That is the first chapter. So, x is equal to, what is the base here? It is e. Log x to the base e here is equal to t. So, x is equal to e raised to t. Okay, this is the most important step. If you know this, because this you have already done in chapter 1. Okay, so x is e raised to t. So if I now second step will be differentiating on both sides. What do I get? One upon here dx is equal to e raised to t dt. E raised to t dt. So what will be my question? Now I have integral of log x whole square dx. So what do I write for log x? I will write it as t. So this is equal to integral of t square. Instead of log x, I am writing t. So this is t square. Instead of dx, what do I write? E raised to t dt. E raised to t dt. Isn't this same as this question, 13th question that we did? Okay, isn't it similar? X square e raised to 3x dx. Isn't it same? Now what do I have? T square e raised to t. Okay, so here the sum that I had solved earlier, the 13th sum. So same thing, we are doing it over here. So you can use the same method and now solve this. Is that clear? So I'm going to solve this in the same method. So what now here, is it following the rule LAE, logarithmic, algebraic and exponential? Yes, t square is algebraic, e raised to t is exponential. So what will this be? What will be my u? U will be t square. What will be my v? V will be e raised to t. So what will I get? What is the integral of uv dx is equal to u into integral of v dx minus integral of du by dx into integral of v dx into dx. Now, what will happen? U is how much? T square. So, this is t square. E raised to t is how much? Integration of e raised to t will be e raised to t minus integral of du by dx will be 2t. T square will be 2t into e raised to t dx. Now here, as you can see, I have t into e raised to t, which means I have to integrate again. So this is equal to t square e raised to t minus 2 bracket integral of t e raised to t dt, which is equal to t square e raised to t minus 2 first function into integration of second function. So 2t e raised to t, because integration of e raised to t is e raised to t, minus integration of derivative of the first function, derivative of t is 1, integral of e raised to t is e raised to t dt. So what do I get here? T square e raised to t minus 2t e raised to t, and what will be this derivative integration? This will be e raised to t minus into minus plus, so this is 2 e raised to t plus k. I resubstitute. What do I get? Instead of t, what am I going to write? Log x. So this is equal to log x whole square. Instead of e raised to t, what am I going to write? X. So this is x log x whole square minus 2. Instead of t, I am going to write it as x log x. Okay. Because t e raised to t. So x is e raised to t and log x is t. So minus x plus 2x plus k, because instead of e raised to t, I'm writing 2x. Let us check. X log x whole square minus 2x plus 2x plus k, right? So A will be the correct answer for question number 16. Just let me check the answer. Yeah, 8. Have you understood, Shiba? Okay. And the others also, I hope you've understood. Just let me tell you, I am substituting log x is equal to t. Then the very important step is writing x as equal to e raised to t. How do I write that? Just go back to chapter number 1. There you will be able to see that log x to the base e equal to t is x will be equal to e raised to t. Okay. And then the second step is differentiate on both sides. Third is substitution, solving the integral, and then resubstituting for t. Now going to the 18th sum. Now this is a question on definite integrals. So what do I have here? It is 0 to 1, 2x square minus x cube dx. So here 0 to 1, 2x square minus x cube dx. This is equal to this is equal to 2 integral x square dx, x going from 0 to 1 minus integral of x cube dx, x going from 0 to 1. What is the integral of x square? This is x cube upon 3. 2 into x cube upon 3 minus x cube will be x raised to 4 upon 4, x going from 0 to 1. Now what do? I will first put the upper limit and then I will substitute the lower limit. So what is the upper limit? Upper limit is 2. Upper limit is 1. So 2 into 1 upon 3 minus 1 upon 4. So how much is this? And minus, what is the lower limit? This will be 2 into 0 upon 3 minus 0 upon 4. Okay, because instead of x, I am putting 0, lower limit. Instead of x, I am putting upper limit. So this is for the upper limit and this is for the lower limit. So what do I get? This is equal to 2 by 3 minus 1 by 4. Let me write it well. So this will become 2 into 1 is 2. 2 upon 3 minus 1 upon 4. What is the LCM? 12. So this is 2 into 4 minus 1 into 3. 2 4s are 8. 8 minus 3 is 5. So answer is 5 by 12. So B will be the correct option. Is that understood? Let us take a similar sum of definite integral. Shiba, which question? Sanjana Lakshmi, which question do you want? 15 question I've already taken, Sanjana. You want to see it? You can always watch it on the this thing also, YouTube. You can revisit You can go to the ICAI tube on YouTube and then you can see. See, this sum I've already done. Okay. Any sum, suppose you missed because maybe you took a break or there is any network issue, you can always rewatch it on YouTube. You should always do that for all subjects, Watch those videos again and again. And especially maths, because you may, if you get stuck when you are solving on your own, you can go back to the video and see. Okay. Good, Mayur, Bhumika, Shiba, you understood. Very good. Yes, Priyanka got the answer. Chandan, Riddhi, Dipanshi, yeah. Yes, Dipanshi, I have not taken the 17th sum because it is a very big sum. For that method, that is partial fraction method, you will usually get 2 linear functions in the denominator, because 3 functions in the denominator takes a lot of time. So the possibility of that coming becomes very less. So it is better that you take those sums wherein the denominator in the question has linear terms. Okay. Now evaluate this. Okay. As I told you, you can do this by substitution method or you can do it by expansion, because this is a simple quadrat raised to 2. So I can solve this. So I can say 3x minus 2 whole square. I can write it as how much? This is a minus b whole square. Okay, that is a square minus 2x ab plus b square, right? We know this formula. So 3x minus 2 whole square will be, 3x will be a and b will be 2. So this is equal to 9x square minus 2 into 2, 4, 4 into 3, 12. So minus 12x plus 4. 9x square minus 12x plus 4. So integral of 3x minus 2 whole square dx will be equal to integral of 9x square minus 12x plus 4 dx. So what do I have here? This is equal to 9x cube, and I have limits also. Okay, so what are the limits? 2 to 4. Okay, 2 to 4. 2 to 4. So this will be 9x cube upon 3 minus 12x square upon 2 plus 4x, limit going from 2 to 4. So I will put in the upper limit first and then the lower limit. So if I put in the upper limit, what do I get? This is equal to 9 into 4 cube upon 3 minus, okay, I can even simplify this. So what do I do? Now what is this? So 3 ones are 3 threes are 2 ones are 2 6 are. So I have, this is equal to 3x cube minus 6x square plus 4x going from 2 to 4. So what do I have here? This is when I substitute upper limit first. So I have 3 into 4 cube minus 6 into 4 square plus 4 into 4 minus, I will substitute the lower limit. So this is 3 into 2 cube minus 6 into 2 square plus 4 into 2. How much will this be? This is 64 into 3, 192 minus 16 into 696 plus 16 minus plus 16 plus 192. This is equal to 112 minus, what do I have? 2 cube is 8. 8 into 3 is 24 minus 4 into 4 24 plus 8. So plus 24 minus 24 is 0, plus 8 is minus 8. So 112 minus 8, answer is equal to 104. Okay? Right? You can even use the substitution method. Okay, in the substitution method, what do? I substitute 3x. Let me write it with a different color. I substitute 3x minus 2 to be equal to t. So I have 3 dx is equal to dt. So my equation becomes integral. But here you have to even like change the limits. So it is better in this sum that we follow this method only. In definite integral, it is better I follow this method. Otherwise here I have to also change the limits. Okay, so better you don't do that. So you get this answer. Okay. Now here also, okay. Now question number 22. Question number 22 is very again depends on the formula. They are given that fx is equal to under root of 1 plus x square, then integral of fx is. Now this 1 plus x square, 1 plus x square can be written as 1 square plus x square, which is similar to the formula x square plus a square dx. So x square plus a square dx, this formula is there. Integral of x square plus a square under root of x square plus x square dx is x by 2 under root of x square plus a square by 2 log of x plus under root of x square plus a square plus c. Here a is equal to 1. So what will happen? This is integral of under root of x square plus 1 dx is equal to x by 2 under root of x square plus 1, because instead of a square I am writing 1, plus instead of a square again I am writing 1 by 2 log of x plus square root of x square plus 1 plus c. Which answer do I have? X upon 2, x square plus 1. So instead of x square plus 1, I can write as 1 plus x square also. So here you can see x by 2, x square plus 1 plus 1 half log of x plus x square plus 1 plus c. So this is the correct answer. There is a plus k, I think, over there. Yeah, so plus k. So can you see over here that this is the correct answer? So I hope you've understood all the sums I've taken. I've taken all types of sum. Usually the first 6 or 7 formula you need to know very well. And then as you can see, if you know this formula, it is very simple that I am able to do them. Okay, so the basic formula and the formula for square root of x square plus a square, then 1 upon square root of x square plus a square, or integral of 1 upon x square plus a square. Okay, so all those formula, if you know them, then you will not have any issue. So this completes my integration topic. If you have any doubts, please let me know. Okay, so let us meet next time. So have a great evening, be safe, have a great day. Akash? Yes, thank you.